All right, this is problem B4. It's a no calculator problem. And note that we're given the graph of a derivative. And we're going to be asked questions about the actual function, so the antiderivative of that. And we're given this important information. This is some sort of initial value. And so they clearly tell you that this is a semicircle. So ignore that first problem for now. In preparation for what's to come, I'm going to find the areas under the curve for these three separate parts. Because remember, this is a rate curve, and the area under a rate curve will give us information about the antiderivative. And so this is a triangle. I found its area here. A semicircle, 1/2 of pi r squared. Note that that area is negative since it's under the x-axis. And then once again, another triangle with 1/2 base times height. Okay, so now, part A. Find the value of f of -6. Okay, so if I set this integral up, what I'm finding is the area under this curve from -6 to -2. So I would antiderive and I get the antiderivative, which is f, and I have to evaluate it for these two limits. And so just the second part of the fundamental theorem. This area from, I should show you again, from -6 to -2 is just the area under that triangle. So 4, okay, we're given f of -2, and we're looking for f of -6. So we simply solve for that. And it's the same exact process for f of 5. Use the information you're given. So once again, we're given f of -2. So I'm going to find the area from -2 to 5, and it's the same process. Okay, and note here that the area from -2 to 5 includes that semicircle, -2 pi, and this triangle, 3. Then we simply solve for f of 5 again. Okay, so that's part A. Part B, on what interval is f, not f prime, but f increasing? Well, this one's a fairly simple one. F is increasing where its derivative is positive. And so I look at the derivative curve, and these are positive values, and these are positive y values. And so it's increasing on those intervals. Part C, find the absolute minimum of f on that entire closed interval. Okay, so what we have to remember is that a minimum can occur either at a critical point or an endpoint. And critical points are where your derivative is either 0 or undefined. Okay, so we have an endpoint. There we have, this is our derivative again, where our derivative is 0, the derivative is 0 again, and here are both an endpoint and the derivative is 0. So if we have an absolute minimum, it will occur at one of those 4 points, or maybe multiple ones. And so very simply, this is how we first learned this. The different x values I want to check were -6, -2, 2, and 5. And I just evaluate the values for f at all 4 of those points. Okay, we were given this in the initial problem. In part 1, we found both of these. Okay, and so remember, these are the y values. So on the original function, for instance, when x is 5, y is that. And so we want to have a good sense of how big this is. This is about -6. -6 plus 10 is about 4. So this is definitely lower. But I still have to consider f of 2. And we go through the same process that we did for part 1, or part A. And we evaluate f of 2, which is now -6 plus 7, so about 1. And so this is the smallest y value on that entire interval. So this is where we would have our absolute minimum. Okay, then part D. Now we're being asked questions about the second derivative of f at two different x values. Okay, so don't forget, the second derivative is simply the derivative of f prime. The derivative of f prime is the slope. And so when we look at when we look at x equals -5, 1, 2, 3, 4, 5, the slope here, that's just a line. And I would just count rise and run, and I find that my slope is my rise and run -1/2. And so the value of the second derivative at -5 is -1/2. Okay, but then on the second value, x equals 3, here I have to find the derivative of f prime. For the derivative to exist here, we would have to be approaching the same slope from both sides. And clearly we're not, so we would say that f double prime, or second derivative of 3, or at 3, is undefined since the derivatives don't approach the same value. So for tomorrow's question, we're only going to do part of this. So this is, once again, a no calculator problem, and we're going to skip part D because what they were asking for was a limit comparison test problem, and that is now off the test this year. So just do parts A, B, and C. Good luck.